Hi and welcome to Turingtalks. In today's video, we're going to see how tokenizers work. Tokenizers are the unsung heroes behind the scenes, making sense of human language for machines to understand. So in this video, we will see what tokenizers are, explore their use cases, and we will also introduce you to huggingface tokenizers, a leading platform in AI and NLP. So what are tokenizers? Imagine you're trying to teach a robot how to understand and speak human language. The first challenge you will face is how to break down language into pieces that the robot can digest. This is where tokenizers come in. Tokenizers dissect complex language into manageable pieces, transforming raw text into structured form that AI models can easily process. So this seemingly simple step is very crucial, and this enables machines to grasp the nuances of human communication. So think of tokenizers as the chefs who chop ingredients before a meal is cooked. Without this step, preparing complex dishes, or in our case, understanding complex sentences, would be much harder. So through tokenizations, AI systems can recognize patterns, understand context, and generate responses that are increasingly similar to human interaction. So by breaking down the complexities of language into simple digestible bits, tokenizers enhance the AI's linguistic capabilities. They also pave the way for a more intuitive, efficient, and accurate machine learning model. So now that we know what tokenizers are, let's look at Hugging Face tokenizers. If you don't know yet, Hugging Face is a company that is at the forefront of AI and NLP. They are best known for their Transformers library, which has made it easier to access state-of-the-art NLP models. You can also find a lot of tutorials in our blog as well as our YouTube channel on different use cases of using Hugging Face Transformers library. So at the heart of the Transformers library is the Tokenizers model. So Tokenizers model is a powerful tool that is designed to convert text into a format that AI models can understand. So even the Hugging Face tokenizers, there are many ways by which you can implement tokenization. Hugging Face's tokenizers library are very efficient, and also they support a wide range of languages. So these make them versatile tools for global NLP tasks. And this tokenizer library is optimized for performance, ensuring that they can handle large volumes of text without compromising speed or accuracy. And also the Hugging Face tokenizers library is tightly integrated with the Transformers model. So this integration allows for seamless processing of data, readying it for complex tasks like translation, summarization, and sentiment analysis. So basically, if you're building a machine learning model using Hugging Face Transformers library, you can use this tokenizers library to break down complex text into simple tokens that your model can easily understand and train with. Great. So now let's get started with some code. We will use the Hugging Face tokenizers library and try to tokenize a simple sentence. I'm assuming you'll be using a Google Colab notebook. So let's first install the Transformers library. Use the exclamation mark if you're installing it on a notebook. Pip install Transformers. Great, it's done. So first, let's import the auto tokenizer class from the Transformers library. So auto tokenizer is a class that can automatically load the tokenizer based on the pre-trained model that we specify. And in this case, we are going to use the BERT model from Google. So from Transformers, I'll import auto tokenizer. So next, we are going to create an instance of the auto tokenizer class by calling the from pre-trained method. So this is where we specify the BERT model. So tokenizer equal to auto tokenizer dot from pre-trained BERT base uncased. So this tokenizer is designed to work with the BERT model and is configured to not differentiate between uppercase and lowercase letters. That is why the name uncased. Great. The setup is done. Now let's declare a simple string for tokenizing. I'll declare a text and say, hello and welcome to the world of tokenizers. Great. So now let's use the tokenize method of the tokenizer with a sample text as its argument. I'll declare a tokens variable, tokenizer.tokenize the text. So the tokenize method will split the input text into a list of tokens, also called as the words or subwords, that the pre-trained model was trained on. So for models like BERT, the words might be split into smaller units to handle out-of-vocabulary words more effectively. We cannot always say that the machine learning model that we use will know all the words in the English language, because there are also new words that are coming up every day. So we will convert the list of tokens into a list of integers, and these integers are called token IDs. And each integer will correspond to a specific token in the tokenizer's vocabulary. So you'll see this when we look at the output. So since machine learning models don't understand text, we'll be using numbers to represent each token. So token IDs is tokenizer.convert tokens to IDs, and the input will be the tokens. Great. Now let's print both these values and see what comes up. I'll print tokens with tokens and token IDs. Great. So basically this piece of code loads a pre-trained tokenizer for the BERT model, tokenizes the sample sentence, and converts those tokens into their corresponding IDs. These IDs are what a machine learning model will process. Great, here's the response. You can see that the token array contains all the tokens, and then there are also like special tokens like #IZER. This is because the BERT model is trying to simplify these tokens. Each word will not be considered as a token all the time. The model can break words into tokens for it to understand these tokens better. So these ## values help the model to increase its range of vocabulary as it keeps finding more and more words. So I hope this example is clear, and I hope you understand how tokenization is done before a machine learning model is trained with a piece of text. So tokenizers are foundational to NLP, and the Hugging Face Transformers library provides an extensive toolkit for working with them. So by understanding and utilizing tokenizers, we can bridge the gap between human language and machine understanding. So this is how the whole concept of NLP works. Every piece of text should be converted into a token before it is fed into a machine learning model for training. If you have any questions, let me know in the comments. We also have a blog called Turingtalks.ai where we publish weekly tutorials, so you can sign up for it if you're interested. Thank you for watching, and see you soon with a new topic. Cheers.